Scene 2, take 1, action.
In the Solve It, you may have discovered that you can rearrange the corners of the triangle to form a straight angle. You can do this for any triangle. The Solve It suggests an important theorem about triangles. To prove this theorem, you'll need to use parallel lines. So that brings us to the parallel postulate. I recommend you take a screenshot of this one and add it to your notes. The parallel postulate. It states, through a point not on a line, there is one and only one line parallel to the given line. So what that means is, let me switch to my pen tool. If we have a line and some point in space that's not on that line, there exists one and only one line that goes through the point and is parallel to the line that we started with. The parallel postulate. And Theorem 3-11, another one you should screenshot and add to your notes. It states the sum of the measures of the angles of a triangle is 180. So this is something you demonstrated with the paper triangles that I handed out when you tore the corners and you formed a straight angle from the three corners. Vocab, auxiliary line. The proof of the triangle angle sum theorem requires an auxiliary line. And here's the definition. An auxiliary line is a line that you add to a diagram to help explain relationships in proofs. The red line in the diagram below is an auxiliary line. When you know the measures of two angles of a triangle, you can use the triangle angle sum theorem to find the measure of the third side. So that leads us to problem 1, using the triangle angle sum theorem. The question asks, what are the values of x and y in the diagram? So if we zoom in on the diagram, remember we're asked to find the values of x and y. So what I notice is in triangle ABD, I have to zoom out to use the pen tool here. In triangle ABD, we know two of the three angle measures. And we know that all three angles must add up to 180. So we can set up the equation, 59 plus 43 plus x equals 180, and then solve for x. So x is 78. Once we know x, well, we can find y perhaps in a different way. We can see that x and y form a linear pair, and so they must add up to 180, just the two of them. So the measures of those two angles add up to 180. We've already found x, which is 78, and our goal here is to solve for y now, and so we use this equation, 78 plus y equals 180, and find that y equals 102. So your turn. What is the value of z?